Hello dear students, I welcome you all to the today's session of Thermodynamics part 4. In previous class we have discussed regarding work done with respect to change in volume as well as change in pressure. Volume, work, change in pressure, we have that's relationship we have discussed. Wherein isothermal and reversible irreversible processes also we have covered in part 3 of thermodynamics. Fine. So today we will discuss regarding work done with respect to free expansion. We have concluded expression for free expansion as well as compression over gas by taking the example of piston in our last session. So today we will understand work done in respect to free expansion of gas. What will be the expression at last we are going to obtain. So see here I have taken pressure which is external pressure is considered as 0. We are speaking about expansion. Expansion ಅಂದರೆ there is an increasing volume is happening. As it is expansion, I can say there is no need of putting any internal pressure. ಯಾವುದೇ ರೀತಿ pressure ಅನ್ನು apply ಮಾಡೋದು from outside, it is not necessary. Expansion in the sense there is no external pressure is present. As external pressure is not at all present, we consider P external as 0. Okay. Previous ನಾವು piston example ನೋಡುವಾಗ compression ಮಾಡುವಾಗ ಏನು ಮಾಡ್ತಿದ್ವಿ, external pressure apply ಮಾಡ್ತಿದ್ವಿ. Due to external pressure, what was happening? Compression of the gas is taking place. Here there is no need of external pressure. So what I mentioned, P external is 0. So yaವಾಗ external pressure ಐತಿ, in the sense there is no work done. So work done will also become 0. So we know this expression in our previous discussion that W is equal to minus of P external and into delta V. When this P external is becoming 0 here, what will happen? No change in the volume. As there is no change in the volume, what will happen? Work will become 0. Just by introducing this value, that is P external value, it is 0. In this expression, what we get? Work done is going to be considered as 0. So, according to first law we have discussed, first law of thermodynamics, conservation of energy. Neither the energy is created nor it is destroyed. Change of form of energy is possible. So here, according to that first law of thermodynamics, we have delta U is equal to Q plus W. Change in internal energy is directly related to heat transfer and work done. So here, what we have considered delta V, that is work done value, it is coming 0. When you 0 into delta V considered, multiplied by 0, it will also become 0 itself, no change in the volume. So I can write here delta U is equal to Q plus W. Just by introducing the value of W as 0, I will be getting delta U is equal to Q into V. So why I have mentioned here Q into V, that is it is going to be considered change of heat energy with respect to constant volume. V represent ಮಾಡಿರೋದ್ರಲ್ಲಿ it is with respect to constant volume. So change in internal energy with respect to change of heat energy at constant volume. Here I will be considering W is 0. So directly just by putting the value of 0, I will be getting here change in internal energy is equal to QV. So this is the expression what we get, change with respect to free expansion. Free expansion ಒಳಗ work done will be 0, and by introducing that 0 value to the first law, we are going to obtain delta U is equal to Q into V, where V indicates that is change in the heat energy with respect to constant volume. Okay, so this is the last expression what we have seen here. So far we have discussed most important 4 expressions since our change in internal energy and reversible processes, irreversible processes we have considered. Okay, so I have mentioned here some important expressions what are to be remembered, what are to be memorized for exam point of view. They are considered as for isothermal change. What will be the change in internal energy? We have discussed isothermal means at constant temperature, same temperature. Thermal indicates temperature. Isothermal change ಅಂದ್ರೆ ಟೆಂಪರೇಚರ್ ಒಳಗೆ ಯಾವುದೇ ರೀತಿ ಚೇಂಜ್ ಆಗ್ತಾ ಇಲ್ಲ. ಯಾವಾಗ ಟೆಂಪರೇಚರ್ ಚೇಂಜ್ ಆಗ್ತಾ ಇಲ್ಲ, ಕಾನ್ಸ್ಟೆಂಟ್ ಐತಿ, ಅವಾಗ always constant. Is always constant in the sense I will be putting the value as 0. So change in internal energy ella isothermal processing ಏನಂದ್ರೆ constant ಇರ್ತದೆ, it is 0. Fine. So then first law equation for isothermal reversible and irreversible changes. Reversible changes, irreversible changes ittaga how does the expression can be written we are seeing now. So for isothermal change, we know that is delta U is equal to 0. So even in madidini ondsari bartidini, this is also one of the important expression. Now I have isothermal reversible change. What is reversible change? Yesterday we have seen, we have blown the balloon and in that balloon we are slowly releasing the pressure. What will happen? Volume is going to decrease slowly. That is considered as reversible change. And for that reversible change even we have concluded one of the expression, that is Q, change of form of energy, heat energy will be considered as minus W. Okay, so minus W, that will also be written as external pressure we have applied, then we have obtained final value and then we also obtained initial value, it was already present. So P external is equal to V final minus V initial, we get that. So this was considered as important expression for our numericals. Further we are going to make use of this expression. Then what we have? Isothermal reversible change. This is isothermal irreversible change. This is for isothermal irreversible change and this is for isothermal reversible change. Irreversible change, we have obtained this expression. Yesterday we have done this one in our previous session. Fine, it will be considered as Q is equal to minus W. In order to remove the land value, we have taken inerting land Pf divided by V initial, and that value we have written here. Due to change in land to log for natural logarithm, what we write here? 2.10 of the inerty log Vf by Vi. Vf is volume, final volume. Vi is considered as initial volume. So simply whatever we have derived in our last session, I just have mentioned here. Their expression, final expressions I have mentioned. Next is for adiabatic change. Adiabatic change we have seen there is no change, transfer of energy, heat energy ಯಾವುದೇ ರೀತಿ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗೋದಿಲ್ಲ, ಬಟ್ ಮೆಕ್ಯಾನಿಕಲ್ ಅಥವಾ ನಾವು ಎಲೆಕ್ಟ್ರಿಕಲ್ ವರ್ಕ್ ಅನ್ನು ಪರ್ಫಾರ್ಮ್ ಮಾಡಬಹುದು. ಅಂತ ವಾಲ್ಗೆ ಏನಂತ ಕರಿತೀವಿ? ಅಡಿಯಾಬ್ಯಾಟಿಕ್ ವಾಲ್. ಆ ರೀತಿ ಅಡಿಯಾಬ್ಯಾಟಿಕ್ ವಾಲ್ ಇಟ್ಕೊಂಡು ಮಾಡಿರುವಂತ ವರ್ಕ್ ಅನ್ನು ಏನಂತ ಕರಿತೀವಿ ನಾವು? Adiabatic work or adiabatic change. So when you consider Q is equal to 0, why Q is equal to 0 for adiabatic change? There is no change of or there is no exchange of energy. Energy adiabatic wall through exchange ಆಗಲ್ಲ, absorb ಆಗಲ್ಲ, liberate ಆಗಲ್ಲ. ಅದಕ್ಕೋಸ್ಕರ ಏನಂತ ಬರೀತೀನಿ ನಾನು? Q is equal to 0 ಬರೀತೀನಿ. ಯಾವುದಕ್ಕೆ? For adiabatic change. Then what will happen? W, that is delta U, change in internal energy ಏನಾಗುತ್ತೆ? Whatever the adiabatic work is done, ಅದಕ್ಕೆ ಏನಾಗುತ್ತೆ? Equal ಆಗುತ್ತೆ. Getting what I am telling you? So this will be explained or understood by considering the adiabatic one. Imagine it is adiabatic one. ಇಲ್ಲಿಂದ ಯಾವುದೇ ರೀತಿ heat energy absorb ಆಗಲ್ಲ, liberate ಆಗಲ್ಲ. That is the reason why we consider Q is equal to 0. Just by immersing any of the rod, we can make certain work inside the system. Our work, changing work, what we call it as? We call it as adiabatic change. Adiabatic change ಯಾವುದಕ್ಕೆ ಯಾವಾಗ equal ಇರ್ತದೆ? Change in internal energy. Change in internal energy ಹೇಗೆ represent ಮಾಡ್ತೀರಿ? delta U. Adiabatic work ಅನ್ನು ಹೇಗೆ represent ಮಾಡ್ತೀರಿ? WAD. So this is the important terms. These are up to here whatever discussed since the beginning of thermodynamics. These are most important 4 expressions we have to remember. Okay. Now having discussed all these points, we are going to introducing one of the newest part or newest topic, that is enthalpy. Now question arises, what do you mean by enthalpy? Enthalpy ಅಂದ್ರೇನು? So enthalpy ಅನ್ನು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋಕ್ಕಿಂತ ಮುಂಚೆ ನಮ್ಮ natural whatever the reactions are being carried out in atmosphere, free space ಒಳಗೆ ಯಾವ reactions ಏನೇನು perform ಆಗ್ತಾವಲ್ಲ, they all are under constant pressure. Constant pressure ಅಂದ್ರೆ ಯಾವುದೇ ರೀತಿ pressure variation ನಾವು breathe ಮಾಡ್ತೀವಿ, it is in open space. We perform certain work that is in open space. ಯಾವುದೇ ರೀತಿ pressure ಅನ್ನು ನಾವು change ಮಾಡಲ್ಲ. Pressure will be remaining constant. change of form of energy at constant pressure is represented by enthalpy. Enthalpy ಯಾವಾಗಲೂ constant pressure ಒಳಗ consider ಮಾಡುವಂತ factor. So change in heat content we can call it as heat content modified above at constant pressure will be represented as enthalpy. So enthalpy ಇನ್ನೊಂದು consider ಮಾಡುವಂತ factor ಯಾವುದು? It is considered as state function. State function ಅಂದ್ರೆ system has achieved one fixed state with a fixed any of the values, but ಯಾವ ಪಾರ್ಟ್ ಅನ್ನು ಚೂಸ್ ಮಾಡಿಕೊಂಡು ಚೇಂಜ್ ಇನ್ ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ ಆಗಿದೆ ಅದನ್ನ ನಾವು ಸ್ಟೇಟ್ ಫಂಕ್ಷನ್ ಗೆ ರಿಲೇಟ್ ಮಾಡಿಲ್ಲ. ಸ್ಟೇಟ್ ಫಂಕ್ಷನ್ ಯಾವಾಗಲೂ ಇಂಡಿಪೆಂಡೆಂಟ್ ಆಫ್ ದ ಪಾತ್ ಚೂಸನ್ ಟು ಅಚೀವ್ ದಟ್ ಸ್ಟೇಟ್. State function is nothing but we consider only state is achieved, but what path we have chosen to reach that state is nowhere considered for the state function. So I can say that enthalpy is considered as state function. Fine. So most of the chemical reactions which are taking place in the open air, that all are considered at constant pressure. So I can write here change in internal energy delta U will be written as Q into W. Q ಅಂದ್ರೆ change of form of energy, change in heat content. Heat content change agada ಯಾವ ರೀತಿ at constant pressure. So I write here change of energy at constant pressure, that is represented as QP. Okay, volume constant ಇದ್ದಾಗ ಏನಂತ ತಗೋತಿದ್ದೆ ನಾನು, I used to consider as QP. Here what I am considering, pressure is constant. Pressure constant ಇರೋದ್ರಿಂದ ಏನಂತ ಬರೀತೀನಿ QP minus of work done is nothing but change in volume. Volume is talking about delta V ಅಂತ consider ಮಾಡ್ತೀವಿ. So change in pressure and volume will be represented as P delta V. This expression has come with the previous discussion what we have done. Okay, so delta U ಅಂದ್ರೆ change in internal energy. ಹೆಂಗೆ represent ಮಾಡ್ತೀವಿ ನಾವು? Final value of internal energy minus initial value of internal energy. U2 minus U1 ಅಂತ ಬರೀತೀವಿ ಇದನ್ನ. Initially in the first session we have discussed. Then it will be represented as QP. QP as it is we have written. P delta V indicates in the sense that change in volume. Final volume minus initial volume. V2 minus V1. So take this term this side QP. Then it will become U2 plus PV2 minus of U1 plus PV1. So this is a modification what we by using this expression. So I can write here QP, that is heat transfer at constant pressure. Heat transfer at constant pressure can be written as PV2 minus Q1 is nothing but change in, you can remember, you can see here correct ಆಗಿ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. PV2 minus Q1 ಅಂದ್ರೆ internal energy pressure volume relationship ಅನ್ನ we are considering it as H2. What does this H indicate? It is nothing but enthalpy. H is nothing but enthalpy. Delta H if you are writing, delta H is nothing but change in enthalpy. So what we consider PV2 minus U2 plus PV2 we are considering as H2 minus of U1 plus PV1 is considered as H1. So these are considered as enthalpies. At this U2 PV2 we consider H2 and here for U1 plus PV1 we consider H1. So finally I can write here change in enthalpy is nothing but final value of enthalpy minus initial value of enthalpy. ನೋಡಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಪ್ರೆಷರ್ ಒಳಗ ಯಾವುದೇ ರೀತಿ ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ ಚೇಂಜ್ ಆದರೆ ಅಥವಾ ವಾಲ್ಯೂಮ್ ಚೇಂಜ್ ಆದರೆ ಅದನ್ನ ನಾವು ಏನಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ? we consider it as enthalpy. Enthalpy is directly related to change in volume and change in internal energy but at constant pressure. Pressure ಏನಂತ ಯಾವಾಗಲೂ ಕಾನ್ಸ್ಟೆಂಟ್. So what we write here? QP is equal to delta H. Delta H is nothing but change in enthalpy, that is the final value minus initial value of enthalpy. This is how we have derived one of the new expression for enthalpy. What is enthalpy? It is considered as change in internal energy and change in volume but by considering the pressure as a constant term, and enthalpy is considered as state function. So then what we can write here? Change in enthalpy volume is also changing, internal energy is also changing, but pressure is considered as constant. That time it is considered as enthalpy. Fine. So delta H may be either negative ಯಾವಾಗಿರ್ತೈತಿ positive ಯಾವಾಗಿರ್ತೈತಿ ಯಾವಾಗಲೂ ನಾವು ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಬಂದಿದ್ದೀವಿ. So you can see here it will be negative when we perform exothermic reaction. Exothermic reaction ಅಂದ್ರೆ system ನಿಂದ ಯಾವಾಗ heat release ಆಗಿದೆ then it is referred as exothermic. For all exothermic reactions we know that change in enthalpy value will always be negative. And similarly for delta H positive is endothermic reaction, system is absorbing certain amount of energy, that absorbed energy will be represented as delta H is equal to positive. So we have introduced enthalpy term. Where all we use this enthalpy and what are the applications and all we will see in our next session. Please do copy this. So far we have discussed regarding enthalpy. It is a state function. Everything we have discussed regarding the enthalpy, and finally we have got an expression for enthalpy change also. Now we need to understand what is the relationship between delta H and delta U. How does change in enthalpy and change in internal energy are related to each other? So you can see here relationship between delta U and delta H. Delta U we consider it as change in internal energy. Delta H is considered as change in enthalpy. Okay. So when you consider the differences between delta H and delta U is very much, so much is not significant for the cases of solids and liquids. So what will happen? Mainly we are concentrating on the volume change. What is happening exactly you can imagine here. Solids are they are very closely associated. They show strong force of attraction between them and they cannot be easily removed. ಯಾವುದೋ ಒಂದು ಸಾಲಿಡ್ ಅನ್ನು ಸೆಪರೇಟ್ ಆಫ್ ಮಾಡಬೇಕು, ಬಾಂಡ್ ಬ್ರೇಕ್ ಮಾಡಬೇಕಂದ್ರೆ ನಾವು ಹೈಯೆಸ್ಟ್ ಎನರ್ಜಿ ಪ್ರೊವೈಡ್ ಮಾಡಬೇಕಾಗ್ತದೆ. ಫೈನ್. ಸಿಮಿಲರ್ಲಿ ಲಿಕ್ವಿಡ್ಸ್ ಅನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ, ಸಾಲಿಡ್ಸ್ ಅನ್ನ ಲಿಕ್ವಿಡ್ಸ್ ಅನ್ನ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಏನಿರ್ತದ, ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಈಸ್ ವೆರಿ ಹೈ ಅಂಡ್ ದೇರ್ ವಿಲ್ ಬಿ ಅ ಸ್ಟ್ರಾಂಗ್ ಕೈಂಡ್ ಆಫ್ ಬಾಂಡಿಂಗ್ ಬಿಟ್ವೀನ್ ದೆಮ್. ಆ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಅನ್ನ ಈಸಿಯಾಗಿ ಅಷ್ಟೊಂದು ಈಸಿಯಾಗಿ ಸೆಪರೇಟ್ ಆಫ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ. ಹೈಯೆಸ್ಟ್ ಎನರ್ಜಿ ವಿ ಹ್ಯಾವ್ ಟು ಪ್ರೊವೈಡ್. ಬಟ್ ಹಿಯರ್ change in enthalpy what we consider is only for somehow it is so negligible that highest amount of energy na ನಾವು provide ಮಾಡೋದ್ರ ಬಗ್ಗೆ we are not going to discuss. So mainly we ignore the change in enthalpy and change in internal energy with respect to solids and with respect to liquids. We do not consider them. It is very much negligible. We are neglecting it just. But ಏನಾಗ್ತದೆ, gaseous particles ನೀವು consider ಮಾಡಿದ್ರೆ gaseous molecules need there will be a highest difference in bonding between them. They are very loosely bound together. Weak van der Waals force of attraction will be operating between them. Okay, these all things we know. So due to that all those conditions, gaseous particles will be showing us variable changes with respect to volume, pressure, everything. So we are mainly concentrating on the gaseous particles for the relationship of delta U and delta H. Okay. So when you consider for gaseous particles, here what will happen? Difference in delta H and delta U for solids and for liquids. If you are considering, delta H is always directly equal to delta U. So this is expression what we write for directly solids and for liquids. Liquids in the solids in the consider ಮಾಡಿದ್ರೆ relationship between delta U and delta H they have become equal to each other. But here what happens for gaseous particles you can see. But for gaseous particles change in enthalpy is considered as change in volume. But the thing is pressure will be constant. Pressure in the constant. Pressure constant ಇರೋದ್ರಿಂದ ನಾವು ಇದನ್ನ ಕರೀತೀವಿ change in enthalpy ಅಂತ ಕರೀತೀವಿ. Enthalpy will be considered criteria under constant pressure. Okay. So here the difference in the delta H and delta U however becomes more significant when gaseous particles are involved or gases are involved. That will be written mathematically. Mathematical expression of relationship of delta H and delta U will be written so. So I have taken VA, VB, NA, NB terms. So here these are respective volume change with respect to reactant A and volume change with respect to reactant B. Here number of moles of gaseous particles for A and number of moles of gaseous particles for B I will be writing. So I will give these terms later. Just imagine that I have ideal gas equation. So ideal gas equation we have discussed, that is PV is equal to nRT. States of matter ಒಳಗೆ ideal gases, non-ideal gases ಎಲ್ಲದರ ಬಗ್ಗೆ ನಾವು ಓದಿದ್ದೀವಿ. So ideal gas equation is PV is equal to nRT. I will be writing. Here I have PVA, that is reactant molecule A, is giving us NART just by introducing these reactant terms. These are called as A are nothing but reactant terms. So similarly I have B. These are product terms. B is nothing but product term. So by just subtracting these both equations 1 and 2, what I do get here? I have PVA is equal to NART, PVB is equal to NBRT. Just by subtracting these two, I will be getting P of VB minus VA, P of VB minus VA. Take this pressure terms common. Here what happened? Na minus Nb minus Na, products minus reactants I consider. Then I have RT. These are RT. So here VB minus VA, products aside, this is final volume, this is initial volume. Change in this volume will be written as delta V. This we know already. So P delta V is equal to, we can be considering as Nb minus Na, in the sense we can consider it as change in number of moles of gaseous particles. That will be directly written as delta nRT. ಅದನ್ನು ನಾವು ಡೈರೆಕ್ಟ್ ಆಗಿ ಏನಂತ ಬರೆಯಬಹುದು? delta nRT ಅಂತ ಕೂಡ ಬರೆಯಬಹುದು. So where now I will consider P delta V. ಹಿಂದಿನ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಲಾಸ್ಟ್ ಸೆಷನ್ ಒಳಗೆ ಮಾಡಿದ್ರು. So ಹಿಂದಿನ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಒಳಗೆ ಏನು ಬರೆದಿದ್ವಿ ನಾವು? P delta V is nothing but delta H minus delta U ಅಂತ ಬರೆದಿದ್ವಿ. By using this expression, substitute in this one. P delta V I have here. So P delta V ಅಂದ್ರೇನು? Delta H minus delta U. ಈ expression ನಾವು ಮಾಡಿದ್ವಿ already. So just by introducing this value, P delta V ಇದನ್ನು ಏನು introduce ಮಾಡ್ತೀನಿ? Delta H minus delta U. Then what I do consider? It will be delta nRT. So just by delta H minus delta U, delta the main relationship of delta H, change in enthalpy, with that of internal energy, change in internal energy. So delta H is equal to, in minus into the delta U, now it is positive delta U plus delta nGRT. This is what your final expression I do got here for, this is considered as expression only for gaseous molecules. Expression only applicable for gaseous molecules. So delta H is equal to delta U plus delta Ng. G represent ಮಾಡ್ತಿದ್ದೀವಿ. G gaseous particles ಅನ್ನು represent. It is representing. So where is delta N, that is change in number of moles of, see you can see here, difference in the number of moles of gaseous reactants and gaseous products. Delta N. So delta N is the number of moles of gaseous reactant molecules. Delta Nb is the number of gaseous these product molecules. Number of moles of products it will be. Okay. So this is how we will be getting the final equation for change in, it is relating change in enthalpy and change in internal energy, how they are related to each other. Solids anna liquids anna ತಗೊಂಡ್ರೆ delta H is directly equal to delta U ಆಗುತ್ತೆ. But gaseous particles ತಗೊಳ್ಳೋದ್ರಿಂದ volume will be changing, but the thing is pressure will be constant. And now we can finally get the expression delta H is equal to delta U plus delta nGRT. So it is clear here that, listen, so here V is nothing but total volume of the gaseous reactants, as I have already told you, NBT is total value of gaseous products. Similarly, Na is number of moles of gaseous reactants and respectively NB is number of moles of gaseous products. So these are the terms which exclusively we made use of to get this final expression, which is mainly giving us relationship between delta H and delta U for gaseous particles. This expression is only for gaseous molecules, gaseous particles. That is delta H is equal to delta U plus delta Mg RT. For solids and liquids, what will happen? Delta H will directly equal to delta U. Please do copy this.